Tech in 5.
Ever wondered how top tech companies evaluate coding skills in interviews? Mastering coding challenges is your key to securing that dream tech job. Ever struggled with checking a Sudoku board's validity? Stick around. By the end of this video, you'll know exactly how to write a function that does just that. Sudoku is played on a 9x9 grid, divided into 9 smaller 3x3 boxes. The goal is to fill every row, column, and box with digits 1 to 9, without repeating any numbers within them. To determine if a Sudoku is valid, we don't need to solve it. We just need to ensure these rules are followed. Let's break it down. Every row must be checked for duplicates. Every column must be vetted in the same way. And each 3x3 box must also have no repeated numbers. Each row, column, and 3x3 box is a collection of 9 numbers. So, the real challenge here is figuring out a smart way to check if a collection has only valid elements and no repeated elements. Checking for duplicates and validating elements within a collection can be approached in several ways. I will explain these methods. First, using a set to track uniqueness. Iterate through the collection, checking if each element is valid. Check if they are number 1 to 9. As you check each element, attempt to add it to a set. Because sets do not allow duplicates, if element has already exists, you found a repeated element. Another way is using set with all valid elements. You create a set containing all valid elements, numbers 1 to 9. Then, as you iterate through the collection, check if the element exists in the set. If it does, remove it from the set. If it doesn't exist, either it is invalid, or the element has already been removed. Either way, the Sudoku is not valid. If not using set, Boolean array can be used for flagging. You can use a fixed-size Boolean array, where each index represents a potential number in the collection. As you iterate through the collection, check if the Boolean at the index of the current element is true or not. If not, set it to true. If it's already true, you found a duplicate, because the number has been encountered before. These are most common way to solve this problem, but let's check other ways as well. Another approach would be to sort the collection first. Once sorted, any duplicates will be adjacent, and you can simply check each element against the next to detect a duplicate. This also helps in validating the numbers, as you can easily spot numbers outside the valid range. Hash map or dictionary can also be used as alternative solution of set. Use a hash map to keep a count of the numbers. As you go through the collection, increment the count for each number in the map. If you increment and find the count goes above 1, then a duplicate exists. The other two methods are more language-specific because not all languages support them. When dealing with a fixed range of numbers, you can use a single integer and bitwise operations to set flags for each number encountered. This is a compact and efficient way to check for duplicates. If you are working on languages that support functional programming, like Java 8 and above, you can use stream operations to filter invalid numbers and use a collector to ensure there are no duplicates. Let's get our hands dirty. I'm using Python to implement the first option. As example, the function is validBlock as a helper function that takes a sequence of numbers, which could be a row, column, or box from the Sudoku board. It first checks that the length of the filtered block is equal to the length of the set created from the block. Since sets automatically remove duplicate values, this step ensures that there are no repeated numbers. Then, it checks that every number in the block is between 1 and 9 inclusive, using the all function. The solution function iterates through each row in the board and passes it to the helper function. It then checks each column by constructing a list of numbers in each column and check the list with the helper function. The function uses two nested loops to iterate in 3x3 box increments. It constructs a flat list of the numbers in that box and passes it to the helper function. Now let's take a look at time and space complexity. There are n rows, n columns, and n boxes. This gives us a total of 3 n units to check. Each unit contains n elements, and we use a set to check for duplicates, which is an O of 1 operation for each element. Therefore, we perform n checks for a single unit. Since we perform n operations for each of the n unit, multiplying these together, the total time complexity is big O squared. For space complexity, the additional space is for storing the set of numbers encountered in each unit. Because we are only storing a single unit at a time, the space complexity is big O of n, where n is the number of possible values. Got a different solution? Feel free to share your ideas in the comments.
Stay tuned for more videos on Tech in 5.